Right, welcome to the set of wave function exam questions. There's only 5 questions here and every one of them involves a wave function. What I'm going to do is I'm just going to do the first couple so you can see the process, and after that I'll pause the video and just do all the working so you can have a quick look at it without having to listen to me go through repeated wave function questions. So the first one here is 8 cos x minus 6 sin x is equal to k cos x plus a. Okay, now we like the wave function. The wave function is the same all the time. The one thing you have to be careful of is you get your correct expansion. So this one's going to be cos x cos a minus sin x sin a. And then when you multiply out by the k, it's k cos x cos a minus k sin x sin a. Okay, so then you compare your coefficients to get your k cos and your k sin. So cos x is here, cos x is here. So attached to this is k cos a. Attached to this is 8, so k cos a has to be the same as 8. Sin x is here, sin x is here. So negative k sin a is equal to negative 6, which means k sin a is equal to 6. K is the square root of 8 squared plus 6 squared, which is 10. And tan alpha, or tan a in this case, sorry, is k sin a over k cos a. Okay, so tan a is equal to 6 over 8. Okay, now we need to check what quadrant it's in. Both cos and sine are positive, so sine's positive here, cos is positive here and here, which means we're looking at the first quadrant, and we do the inverse tan of 6/8. Which gives you 36.9, so A is 36.9 degrees. Okay. Looking at marks, you're going to get 1 mark for expanding correctly, 1 mark for getting your k sin and your k cos correct, 1 mark for your k, and your 4th mark for A. One thing you could do is just a bit of housekeeping at the end is rewriting this whole thing, but sorry, I just missed that out there. Okay, looking at the next one, got a very similar idea. 2 sin x minus 5 cos x is equal to k sin x minus alpha. Making sure we get a right expansion, that's going to be sin x cos alpha subtract cos x sin alpha. And then multiplying out is k sin x cos alpha minus k cos x sin alpha. Okay, so comparing our coefficients, sin x is here, sin x is here. Attached to this sin x is k cos alpha, and that's equal to 2. Attached to this cos x is minus k sin alpha. Attached to this cos x is minus 5. So k sin alpha is equal to 5. K is equal to the square root of 2 squared plus 5 squared, which is root 29. And then tan alpha is equal to k sin alpha over k cos alpha. So tan alpha is equal to 5 over 2. Checking our cast diagram again. Cos is positive, so there and there. Sine is positive, so here and here. So again, we're in our first quadrant, like that. Inverse tan of 5 halves is equal to 68.2. So that means alpha is 68.2 degrees. Okay, so marks again. First is for your expansion, second for your k cos and your k sin, third for your k, and fourth for your angle. Okay, so this is a different one, 2-part question. First one is using the wave function to turn it in, and the second one is talking about maximum minimum value. Okay, so I'm just going to do the wave function in just a second, and just you can have a wee pause and look at it, and then I'll just go into B and explain that fully. Okay, so if you want to pause and have a wee look at that, make sure we're okay. That's just your sine rule for this question. Okay, now looking at part B, you want to know the maximum value of 5 plus sine x minus 3 cos x. Now this here is what I've changed, or what we've changed in part A to your wave function. So really what this means is 5 plus root 10 sine of x minus 71.6. Now you're looking for the maximum value. Now the one thing you can control is x, which is part of a sine function here. Now the maximum value of a sine function is 1. Okay, we know from all our sine graphs, the maximum value of just a sine graph there is 1. So the maximum value happens when sine of x minus 71.6 is equal to 1. Okay, now I'm going to write this out fully. So sine of x minus 71.6 is equal to 1. Okay, that's when your max value happens. So that means max value is equal to 5 plus root 10 times 1. Okay, so just 5 plus root 10. Okay, now that's a lot of work in there just for being able to look at that and see. That's fine, that's only going to be 1 mark. Now the second part is state a value of x for which this maximum occurs. Now the sine graph equals 1 at that point there. Okay, when you're doing sine of 90. Okay, so that happens when x minus 71.6 is equal to 90 degrees. Because if you put 90 degrees in there, that's going to give you 1, which is a maximum for that function. So x is equal to 161.6 degrees. Okay, and just for the marking for there, it's just a mark for stating the maximum value, and then a mark for knowing the x when that happens. Okay, I'm going to do the same here. I'm just going to shoot up the wave function. You can have a wee look at it yourselves. Okay, so there's your wave function completed. Just have a wee second and check that that's all okay. Okay, so part B after your wave function is hence solve algebraically f of x is equal to 0.5. Okay, so firstly, there's that word hence. Okay, we're going to use what we did in part A to answer part B. Okay, so in part A, we changed f of x, which was this 2 cos x plus 3 sin x, into a wave function. And now we're trying to solve f of x is equal to 0.5. Okay, so f of x is equal to 0.5 really means here 2 cos x plus 3 sin x equals 0.5, and after we've changed it, it will be root 13 cos x minus 56.3 is equal to 0.5. Okay, first thing to notice now we're solving this equation is, right, well actually we've only got one trig function, so this is going to be cancelling things out, getting rid of it and just dealing with it as it comes. So firstly we're going to divide by the root 13, and then we're going to get rid of the cos. Now I'll just do it over here. Okay, so we're going to do a cast diagram. You have cos of a positive, so we're dealing in quadrant 1 and quadrant 4. So inverse cos of 0.5 over root 13, that is equal, give me a second, sorry. That is equal to 82.0. Okay, so this thing here after you've got rid of the cos, x minus 56.3 is going to equal 82.0 in the first quadrant, and 360 take away 82, so 278 in the fourth quadrant. Okay, which means when you add 56.3 on, it's 138.3, and 334.3. Okay, now this is just a normal 1x wave, so you could add on 360, it's going to take you outside the range. Those are your two answers there. Okay, let's have a wee look at marking. Okay, first marking part B is for subbing in the wave function. Second mark is for starting to solve your strategy, and your third mark is for your answers. Okay, now I'm going to go through this last question fairly just because it's just slightly different. Okay, so firstly we've got displacement, blah, 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 given by this formula, and we want to express d in the form k cos 20t minus alpha. Okay, so for part A, we want cos 20t plus root 3 sine 20t to equal k cos 20t minus alpha. Okay, breaking out with your expansion is k cos 20t cos alpha plus sine 20t sine alpha, which becomes k cos 20t cos alpha plus k sine 20t sine alpha. Okay, comparing coefficients, this time we're comparing cos 20t's rather than just cos t's. Okay, so cos 20t there is cos 20t there. Attached to this k cos 20t is k cos alpha. Attached to this 20t, well, it's just a 1. Sine 20t is here, sine 20t is here. So k sine alpha that's attached here has to be equal to root 3. K was going to be the square root of root 3 squared plus 1 squared, which is just root 10. And tan alpha is equal to k sine alpha over k cos alpha. Make sure those k's are there as well. Okay, which is root 3 over 1 or just root 3. Okay, looking at a cast diagram, again we're positive in every for sine and cos. Inverse tan of root 3 we know is 60. Yeah, we're in degrees and that's good, so it's 60. So alpha is equal to 60 degrees in that first quadrant. Okay, so cos 20t plus root 3 sine 20t is equal to root 10 cos 20t minus 60. Okay, for part B, we're sketching the graph. Okay, give me a sec, I'll just tidy this up to give me some room. So I'm going to do some marking first. So first one for the expansion, second one for your k cos and k sine, third one for your root 10, and fourth one for your 60. Okay, so for part B, we're looking to sketch this graph. Okay, now firstly we've got a cos graph. There's root 10 at the front with a 20t minus 60 at the front. Now, just for a wee bit of housekeeping, we're going to have root 10 cos, and actually what it is 20t minus 3 with that common factor. Okay, so it's root 10 cos 20t minus 3. Now, without even worrying about that minus 60, we know this root 10 is going to be the amplitude. We know we've got a cos wave, and we know the 20t means that you've got 20 waves in 360, which means we've got one wave in 360 divided by 20. We've got one wave in 18, which is nice and handy because of this range we've got here. Now what I like to do first is ignore just the phase shift first, the minus 3. I'm just going to draw root 10 cos 20t. Okay, so I'm going to have a cos graph, and you forgive how messy this will be. It's root 10 by, and then minus root 10, and one wave is in 18. Okay, now I'm just going to do it in a different colour. The 20t minus 3 now is just going to move this whole thing from, well, that's 4.5 and that's 13.5, just from the midpoints of that. This whole graph is going to move sideways 3. Okay, so it's going to move from here, down here, up here, and back out. And just to finish it off, I'm just going to have that there. So that point is at 3, this point here is at 7.5, and this one's at 16.5 there. Okay, so that's your graph. You know what the root 10 does, you know it's a cos graph, you know there's 20 waves in 360. Just remember, if you've got that 20t in with your phase shift, you need to take out the common factor so it's easier to move. Okay, now I'm going to do my marking, I'll do it in blue just for a wee change. Your first mark is for the correct wave, your cos wave. Your second mark is for your amplitude, your root 10 and minus root 10. And your third mark is for one wave in 18. and then your fourth mark is for the correct phase shift, moving it right 3 places because it's a -3. Okay, I hope that's clear. Now part C. Find, in fact, I'm just going to do some wee bit of admin. Give me a wee second again. Okay, so lastly, just for part C, find the correct one decimal place values of t for which the displacement is 1.5 units. Okay, so the displacement we know we've turned into this equation from part A. Now we want to know when that's equal to 1.5. Okay, so this here is the equation we've got to solve. Again, cos t, we've got cos 20t minus 60, that is a single trig function. So we have to cancel everything out and get it to the other side. So root 10 is going to divide by first. So cos 20t minus 60 is equal to 1.5 over root 10. We're dealing with a cos function. And it's positive, so we're going to make quadrants 1 and 4. Okay, the inverse cos of 1.5 over root 10 is equal to 61.7. So this here, after you get rid of the cos, 20t minus 60 is equal to 61.7. And in the fourth quadrant, it's going to be 298.3. Okay, so we're still solving, adding 60 to both sides. 20t is 121.7 and 358.3. And then divide by 20 is 6.09 and 17.9. Okay, now you want, find correct to one decimal place, the values of t between 0 and 18. Okay, so that's between 0 and 18. We could add 18 to get the next way, but obviously it's going to come outside. And to one decimal place, that's 6.1 and 17.9. Okay, so that's your values of t for which your 1.5 is the displacement. Okay, so the first thing is, the first mark is for setting it equal to 1.5. The second mark will be for getting 61.7 and 298.3, and the third mark is for your final answers. Okay, thanks for listening. Any issues, give us a shout. Well, that's been helpful.